All right, so lesson 5 here. We're talking about properties and we're talking about operations. So what we're going to look to do here is we got some vocabulary words that we're going to be making use of. And a lot of this just kind of explains why we can go out of order in our order of operations, and it's still going to work out just fine. So the commutative property. The commutative property works for addition and multiplication. And what it says is, hey, listen, if it's all addition, you can add in any order that you want. And if you want to multiply a whole bunch of numbers, you can multiply them in any order and you will still get the exact same answer. Shocking, I know. So let's look at this. So we're saying is 4 plus 7 is the same as 7 plus, 4. And again, 11, 11. 5 times 8 is the same as 8 times 5. 40 and 40. So 12 plus m is the same as, yes, taking m and adding on to 12 there. So again, commutative, we can do it in any, or we can flip the order around and it's not going to make a difference. The associative is a lot like the commutative. Commutative, though, just uses two terms, a 4 and a 7, and then we flip them, a 5 and an 8, and then we flip them. Associative is when you've got kind of like a list of numbers. So if we've got 3 numbers or more. So it kind of like saying is, listen, 9, if I do 3 plus 7 first, okay, I'm actually going to get the same answer as doing 9 plus 3 first. So the numbers will stay in the same order. It's just the parentheses or the grouping that will end up changing. And if we check the answer here, 3 plus 7 is 10. 10 plus 9, 19. Over here, 9 plus 3 is 12. 12 plus 7, it's 19. The main idea is this. When you go to the grocery store, it does not matter what order you put the food on the little conveyor belt. It's not like, oh, if I put the Fruity Pebbles first, then followed by this can of Manwich, then I'm going to get a different total. No, you still get the same total when you walk out of the store. So multiplication is the same idea. The order's not going to make a difference there, or from a standpoint of when I multiply. So 8 times 5 and then times 10 is the same as doing 5 times 10 and then times the 8. Again, they did not change. 8 times 5 is a 40. 40 times 10 is 400. Here, 5 times 10 is 50. And guess what 8 times 50 is? 400 there. So let's take a moment to look at 3 and 4. All right, for number 3, again, order, we're going to move the parentheses, so you should have a y that's in there. Again, x, y, z. This guy here, it's just written a little bit funny, so if we clean it up a little bit, I got 5 times. When you multiply a number and a letter together, we always put them right up against each other. It's just our good math grammar. But really what you've got is this, 5 times 4 times c. So you can see, sorry. All right, that's why we're going to have 5 times 4 and then multiply it times the c. A number or a letter up against parentheses does mean to multiply. So they just kind of use a little bit of a different multiplication symbol there, but that's it. Okay, so next property, additive inverse property. Okay, and what it's saying here is if when you add the numbers opposite, which is the additive inverse, so you're always going to get 0. All right, so 8 plus negative 8, yep, that's going to be 0. Because again, it's the integer, remember, positive or negative whole number, that is the same distance from 0, but on the opposite side of the 0. So anytime we add two opposites together, we get 0. All right, so I know I get 0, so the opposite of negative 23 is 23. I know I got to get 0, so the opposite of 37 is a negative 37. If you notice there, I wrapped it in parentheses. A lot of times in math, we don't like two symbols right up against each other, so we use this parentheses just to kind of separate it. It's not required by law, but it is going to kind of help kind of clarify things. All right, so let's see here. Next one we've got is our friend, the distributive property. And the distributive property allows us to combine multiplication and addition together. Now, the thing, though, is how we end up handling it there. So watch what happens. I know, dramatic, huh? Remember, a number up against parentheses means to multiply. But wait, there are two numbers that are inside the parentheses. So we got to multiply to both of them. So this is the same as doing 9 times 2. and then plus, and then 9 times 4. If we do order of operations, 2 plus 4 is 6. 9 times 6 does give me 54. If we come over here, 9 times 2 is 18. 9 times 4 is 36. Well, guess what 18 plus 36 is? It's 54. So again, it allows us to do other things. And we're going to see this especially with our variables right here. So distributive property, 7 times 5, 7 times 5, and plus 7 times x, 7 times x. So if we would clean this up, this would really be 35 plus, and then 7x. Here, 11 times y, all right, is 11y. 11 times 8, all right, is 88. I apologize, we had a typo that's there. You can do it with subtraction, so let's just make this a subtraction sign that's in there. So really it would be 11y minus, and then 88. So again, it is what we call simplifying. I didn't really like that grammar there. But anyway, so the distributive property, when you can't combine, it allows us to move further with a problem. So make up your own there. Take a moment, pause it right here, get some ideas down, and we will get some answers to go along with this. Do you need some music while you wait? No? Okay. All right. All right. So hopefully you've got stuff written down by now. Commutative property, remember this is when you simply reverse them. So I'm going to say 7 plus 3 is the same as 3 plus 7. I could have used multiplication and said 7 times 3 is the same as 3 times 7. That works too. Associative, very similar to commutative, but you need to have 3 numbers. All right, I can wrap parentheses around this, and then that would be the same as, again, keeping them in the exact same order, but moving the parentheses. Additive inverse, I know it's an addition problem, and I know the answer has to equal 0. So I need numbers that are the opposites. So I'm going to go with -5, so that would be added on to a 5. All right. Now, multiplicative inverse. Dear goodness, did I skip over that? I was wondering if you were going to say something about it. Wait, where? It's not? Where? Oh, there it is. You were waiting, weren't you? All right. So let's go back. So multiplicative inverse. This is when you multiply the numbers reciprocal. Okay. When you multiply numbers reciprocal, we call it the multiplicative. I like saying that word. Multiplicative inverse. Go ahead, say it. But when you multiply it by its multiplicative inverse, the answer is always 1. And another word for multiplicative inverse is its reciprocal. So if you notice 9 and 1/9, 1/9 is the reciprocal of 9. They are multiplicative inverses, so your answer is always going to be 1. If I'm going to multiply it by something, I know the answer is 1. All right, the inverse, the multiplicative inverse, so I flip it around, so it's 6. And the last one here, ooh. All right, so typically we see reciprocals with fractions. So I'm going to change this guy to a fraction, so that's 4/10. So I could say, hey, let's multiply it times its reciprocal and get 10/4, and that would give me the answer of 1. If you simplified it and used 2/5, then you would be multiplying times 5/2, and that would work. And oh my goodness, what is 10/4 simplify to? Yes, indeed, that is 5/2. But okay, multiplicative inverse, we're going to multiply, and the answer is always 1. So let's go back, and let's get an example down there. Multiplicative inverse. If I'm doing the multiplicative inverse, I'm going to choose something like, how about the number 8? And that means I'll have to times it by 1/8, and I'll get an answer of 1. Again, multiplying a number times its reciprocal. If I wanted to, I now want to do something like 2/3 times 3/2, that would also work because the answer would be 1. Distributive property, remember that means there's going to be a number that's out in front. I'm going to go with a variable here because I'm feeling fancy. And remember here, it's a number up against parentheses. It needs to visit everyone that's on the inside. So 2 times x, you can write it out as 2 and then times the x if you'd like, and then plus the 2 and then times the 3. That's fine. Or again, we can clean this up there. 2 times x, a number times a letter. We just put it right up against each other. And then 2 times 3, yeah, that's our 6 that we like. So this is a lot of vocabulary, so it is just something we have to kind of get used to. The more we use the vocabulary, the more it'll seem like we don't have to spend time making flashcards.